Okay, we'll make this our last video for this section 13.3, the rotating field. And let's look at the actual magnetic field inside of the stator that we've created. And so look with me, if you would, at figure 13.8, and I'll bring it up now. So internal in this stator, this is supposed to represent the magnetic field that is going on in here. And so, let me get it back up for us. So, you know, we're looking at, say, at this point right here, right? And at that particular point, what we would be seeing would be maximum current from phase A. And then we're also seeing 5 amps from phase B and 5 amps from phase C, okay? And, you know, not getting into the right-hand rule and all that sort of thing, but, you know, that gives this flux a certain orientation. But it just so happens, you know, when we look at the combination of the contributions from phase A and B and C, we get an overriding flux pattern, you know, without getting into all the particulars of that, but it has an overall direction. And this arrow here is giving us what that overall direction would be for the combination of the different fluxes from the different phases, which are 120 degrees apart, okay? So that would be at that first point. If I go to the second point here, I see that I have 5 positive from B and 5 positive from A, and I also have 2 negative from phase C. And what that looks like in here is I have maximum current in phase C, then I have 5 amps from B, and I have 5 amps from A. And what has happened though with the flux pattern, it was initially here, and now it is oriented here, okay? All right, I go to the next point on my curve. I go to point 3, and at point 3, B is at 10, and A and C are at 5 each. What does that look like? Well, lo and behold, B is at 10, A is at 5, C is at 5. And of course, this is these, you know, we're picking 5s and 10s because it's easier to follow. You know, it's instantaneous, you know, it's just this instant in time that we get. But again, you know, here, look what happened to the flux pattern, right? It's rotating through. And, you know, we can just continue this march around here, and we're going to see that the flux pattern is going to create a complete circle as it goes through the rotation, okay? So that's where we get this rotating magnetic flux. And then again, I'm going to stick that rotor in here, and that is going to induce a voltage in those rotor bars. It's going to induce its own current with its own magnetic field. The magnetic fields interact, and that rotating stator field is going to drag that cage around as it rotates through. All right, now, so here's my last thing. I want to explain why an AC induction motor turns at one speed. The speed of this rotating magnetic field is going to depends upon the duration of one cycle, right? You know, so one cycle, the duration, how long does it take for it to go through a cycle? And of course, we know that that duration of one cycle, it depends, you know, we talk about that in terms of the frequency, right? So, you know, for like, if this was 1 second, right, this would have a frequency of 1 hertz. If this was 60 hertz, you know, we'd see 60 of these cycles in 1 second. So anyway, so If the frequency is 60 hertz, the resulting field makes a turn in 1/60th of a second. Or 1/60th of a second, there would be, okay, there are, 60 seconds in 1 minute. So we would have 3,600 revolutions in 1 minute if it's at 60 cycles per second. And then to sort of wrap this up, if the frequency were 5 hertz, okay, then it would make a complete turn in 1/5 of a second, or in 1 minute, it would make 300 revolutions in 1 minute. Okay? Now, he says because the speed of the rotating field is necessarily synchronized with the frequency of the source, the speed of this field is synchronized with the frequency of the source that's supplying, the voltage, ultimately the current, and then the magnetic flux. We say that it is the synchronous speed, okay? So the speed of the magnetic field is defined as the synchronous speed of an AC machine. We will see different AC machines, some designated as asynchronous, some designated as synchronous, synchronous motors, asynchronous motors, synchronous generators, asynchronous generators, but by definition, the synchronous speed of an AC machine is defined by the speed of the rotating field. Okay, that's it. That's the hardest, I think the hardest section that we deal with, section 13.3. And now we've wrapped it up with 3 videos altogether.